welcome to another episode of my tutorial in Python. So today I'm gonna talk about how to solve a differential equation, usually the first order differential equation using Euler's method. So whenever you have a differential equation, y dash equals some function of x and y, uh, and then if it's given for certain boundary conditions, let's say the solution y naught at x naught is given, and then if you have the step size to which you can increase the value of x like this, then in that case the solution can be simply written as the Yan solution can be written as the uh, solution one step before that Yan, and then plus Yats, which is the step size, times the value of this function at the solution at the previous step. So by just using the iterative method we can find the solution. So where this Yan is the number of divisions where you divide the interval of x, that's the number of division, and then so x naught is where your initial value is, or the boundary condition is, and then yats is definitely the step size. So for instance, we can use one example to do that. Suppose we have a differential equation x plus 2y. So we have to define that as a function of x and y, and which is y prime, and we need to find the value of y at different value of x. So the boundary condition given is at x equals 0 or y is also 0, and then the step size is given at 0.25. so we are asked to find the solution in between x from 0 to 5 and then show it in the plot. So that's kind of, with the help of this example today, I will try to simplify the Euler's method in Python. So the algorithm or steps would be first import the packages that we need, and then define this differential equation, and then write the program which can solve the differential equation using Euler's method, and then plot that and execute whatever we write there. So that's the steps. Okay, let's see how we can do it. So first, like I said, we want to import the package. So I don't think I will use numpy here. So just by using Python inbuilt function I can do the Euler's method, so I'm not gonna import the numpy. But to display the plot, maybe I should use the matplotlib. So let me import matplotlib dot pyplot as plt. So this will be used for plotting the result. And then step 2, define the differential equation, which is this for our example. So let's define that. Write def to write that as the function, which is the function of x and then y, and we want to return that return what's the value, x plus 2y, x plus 2 times y. So that's my function, but I can write a docstring to explain it better. So I can do like this to write in the docstring is a differential equation where input would be x as an independent variable, and and then y as the dependent variable returns the first derivative of the y, right, which is y prime. Returns, let me say, y prime. So that's the differential equation given to solve, and then write a function for Euler's solution. So like I described earlier, so this is our calculating formula where we use n as this, and then our initial condition is x naught y naught, which is given here, and then h as the step size, right? So okay, so in order to do that, I can write a general function first and then use these values to get the required value. So okay, let me write a general function for Euler's solution. So I will write def Euler, just to write the general. So in that I will give f as the input, which is this f, because I want to fit that here, and then my initial condition, which will be x naught y naught, and then my int value of x, I will set that as xg or x given, and then the step size. So that's my input arguments. So with the help of that, like I said, I can calculate the n value and then simply put that n here to get the required solution. So first let me find the value of n using this formula. So x int value minus initial value of x over s, right? So that will be n equals x int, which will just be the x given, like I said earlier, and then minus x initial value and divided by, okay, let me write it inside the bracket, and divided by x. So that will be my n, but depending upon the int point value of x and then the initial value, so this division can result a non-integer value. So in order to convert that into integer, I will simply write int and then put it inside the parenthesis. So that will give me the integer, but again I want to get the closest integer. So in order to get the closest integer, I will simply add 0.5. That will give me the closest integer value of n. So now this is making sure that I have an integer value of n. All right, so that's how I can define n. Now I can use do, or any kind of if, while, for loop to do the solution here. So in order to, okay, I'll use maybe I'll use for loop. So to do that, first let me initialize some values. So my I should initialize x and then y values, right? But I will, to separate the different different variables, I will use x as, and then x as means multiple value of x, and then y as. So this is simply, these are the empty arrays. I will calculate x as, y as, and then put right here on these arrays. So this is just the initialization, and then after that what I do is I'll define x for my initial value, which will be my starting point of calculation, y as my initial value or boundary value. And then now I can use the for loop for, since I will not be using any kind of integer here, so I don't care what that is. So I just write underscore, that simply ignores whatever I'm using and then does the loop for all the elements. That's what I'm doing here. So for underscore in range n, I will simply write the value of x as the initial value, which will be x0 for the starting, and then it will keeps updating the value of x. So I will simply write x here and then x. So that will be my new value of x, and then after that this is my new value of y, right? So for that, what I can do is y equals y plus x times functional value of x comma y. So here you need to understand that this is one step previous value of x, and then that plus step size gives me the current value of x. Similarly here, this y is the previous y plus some other thing gives me the current value of y here, where the x and y are again the previous values. So whatever quantity is here in the left side of the equal is the current value, and then whatever quantity in the right side is one step previous value. That's how it works in the loop, right? Okay, so now I calculate my x and y for all the value of n. Now what I need to do is I have already created an empty array for the x's and y's. So now I should store whatever x and y I calculated on this. To do that in Python, yeah, I should append that. So let's append my x value in the xs. So to do that, put xs dot append. Inside that, inside the parentheses, just put the x. So now whatever value of x I calculate will be stored in an empty array here, x's. Each time it calculates, it just stores from the right. So that's how I can do it. Similarly for y, append inside parentheses y. So now I can see all the x and y calculated to be stored in x's and y's. So now this is the end of my program. Now I can get the value of x's and y's as the return. So whenever I call this Euler function, then it will give me the value of x and the corresponding y whenever I call this. That's how I can write the Euler's function. But so let's now write the docstring again. That will help me reading this program in future. So calc solves the differential equation. Okay, let me write the first order differential equation. Order differential equation using Eulers method. So here input, so first f, which should be just the function f of x, which is simply y prime, right? That's what it is. And x naught is the initial value of x. Oops, my bad. And then y naught is the initial value of y. Xt is the end point value of x, or simply x at which solution is to be found out. All right, and then x, which should be the step size. Okay, and then what it returns, what's the answer? So returns it returns ex as, which is simply an array of ex values in interval x x0 to x given, right? And then y as an array of y values corresponding to x at the given interval So I mean, each time I do write some code, I always try to write whatever I am doing, because that helps me to easily read whenever I come back in the future. So this is not for the present purpose, you don't need to do it, but this helps me reading it easily and understanding it. Even if someone else is reading this, then he can understand it easily if you have a well documented code. So that's how it does. So let me comment what I'm doing here. Find the number nearest integer. Okay, that's what I'm doing here. All right, so that's how I can do the Eulers. And let's write another function which actually plots my result, and then I can execute the program. So in order to do that, let me write another function called plot Euler. Whenever I give x and y, it should just plot. So I already imported matplotlib.pyplot in the name plt. So whenever I write plt dot something, then it just gets information from the matplotlib.pyplot. All right, so let me create a figure by doing plt.figure. I can write the figure size and all, but that's not where I'm interested in. So I'll just write plt.figure, which simply gives me the default size of the figure. And then I want to write I want to plot my x and y value, and then with the symbol, let's say just circle, and then dot sign, dot sign. And I can write any level, but I'm not interested in writing that, so I'm just dropping it. And then let me write the level. So x level, this just simply writes the name in the x-axis. I will write x values, and then plt.y level. Let me write y values. Okay, and plt dot okay, so that's simple plot program. So these are my functions. I can write docstring to see, because it's a good habit to write plots the solution of the differential equation at individual point. Okay, so yeah, so we are at the end of the session, so let's run this. Oops, what did I do? Okay, range n. Oh, so I forgot to mention in for underscore in range n. So yeah, my bad. All right, so that's done, right? Write a function for the plot. I already did that here. Okay, let me do it step by step. I will simply move whatever I wrote in the previous cell to this. Already done that step. So this is my final step. So what I can do is first call this function which gives me the value of x and y, and then use that x and y to call this function for the plotting. Very simple, right? Okay, so right, this let me just copy it. I'm a lazy person. So in order to call whatever function we define, simply do that. But this will give me the x and y, right? So I'll write, so x simply means multiple values of x and multiple values of y. I'll write just x and y equals something. So here I'm calling this function. Definitely I haven't defined the values of this because these are my input. I need to define it, but first let me write how I can call this. Now after I calculate x and y, I can simply fit this x and y on this function to plot. So let me copy that too and then paste it right here. So whenever I run this, I should be able to get the plot. Okay, so that's my execution code, but I haven't defined the initial value. Okay, let me see what those are. So x not equals 0 and then y not equals 0. X is 0.25. Okay, so this is equals 0. Right, y not equals 0 and then x equals 0.25, and x is the in like I said, this is the end point, right? So the end point is, where is it, pipe 0 to 5, where x naught is 0. So this should be 5. Okay, let's see. Boom. Okay, so here are my x values and then here are my y values. All right, so it looks like it's exponentially increasing. We can change. So the advantage of writing a general code is we can change the values of any parameter and then we can immediately get the solution. That's how I can do it. So one more thing, if you want to display the value of x and then the value of y or anything, then you can simply, you have the x and y, you can simply print it. So let's say I want to print the value of y or solution at x equals 5. Okay, so my endpoint is 5, so I can simply write print and then format string. I'm gonna do that because I will use the value of variable inside that. So format string and then print what I'm gonna print, the solution at x equals, I will use the x equals 5, right? So x equals 5 is the end point of x, so I can simply write x and then the last element of x is, I can call that by using -1 inside the parenthesis. That will give me the last value of x is okay, y. So again I will use the variable y and the last value of that y should be the solution, right? Okay, let's see how it goes. Yeah, at x equals 5 is 1244.09. So that's how we can do the solution of a differential equation first order with using Euler's method. So if you wanna change the variable here, I can copy that, paste it here, and then let's say I wanna change x. Let's say I want to calculate only up to 0 to 2. So just by putting that, I can simply get the solution here. So the advantage of writing a general code is this: you can change the parameter, tweak the parameter, and then see the solution. All right, so okay, let's say you have another function, not just x plus 2y, but you want another function, right? So in that case, you can simply modify this, or you can write another function somewhere else and then fit that right here. Okay, let's do that. Actually, that would be fun to do. So let me define another function, def. I will define name of function as z as the function of x and y, my bad, which will return, let's say, just x plus y. Okay, I'm not gonna docstring it this because this will just be for showing the different approach. So I have now another function. Now I can copy exactly same thing and then paste it here. So instead of passing function f, I will pass function z, and that should give me the solution here. Let's see. Yes. So now here the solution is different, right? Okay, let's print the endpoint solution as well, and then we can compare. All right, so in this case the solution is 4.2, but in the previous case the solution was 8.2. So because we changed the differential equation, so we have a different solution. So by using this approach, you can simply modify the differential equation without modifying the main code here, which is this one. This is the actual brain of the whole thing. You can simply get different answers in the solution of different functions. All right, so that was pretty much it. In summarizing, we can solve first order differential equation if we have the initial boundary condition, and then so one more thing, we can do the other way as well. If we have the number of steps we want to divide the given interval, then also by manipulating this we can calculate the step size. So either question gives us the step size or gives us the number of divisions, or we can simply manipulate this and then solve the differential equation. Okay, thank you so much for watching this video. Have a good one.